Okay, so this is my math project for handout 3-8 curve sketching. This is the function I'm going to be using. So first of all, I do have everything outlined here. First of all, for intercepts, 0 equals x minus 2 to the 3. This gets canceled. 2 equals x. This right here, 2 comma 0. That is our x-intercept. And then since the x squared is in the denominator here, it does not equal 0, meaning that x does not equal 0. Our vertical asymptote is at x equals 0 right here. So we can go back and write these down. And there is no y-intercept because when we test for y-intercept, 0 is in the denominator, so that's impossible. So our only intercept is that, which is an x-intercept. As for symmetry, f of x equals negative x, or f of negative x. Negative x minus 2 to the 3 over negative x squared, which when we simplify this down, we get x plus 2 to the 3 over x squared, which does not equal f of negative x does not equal negative f of x or f of x, which means there is no symmetry. Now increasing and decreasing, our first derivative is x minus 2 squared x plus 4 over x to the 3. If you want to know how I got this, I'll have probably some PDFs linked in the description if you want to look at that. I don't know if that's required for the assignment or not. Anyways, if we do 0 equals x minus 2 squared, cancel that out, 2 equals x, that's one of our critical values. X plus 4 equals 0, negative 4 equals x, that is also one of our critical values. And x to the 3, our asymptote, x equals 0, is going to be another critical value. So when we put that on a number line, the 4, 0, and 2, and just need to do some testing now. Less than negative 4. Negative 4 is less than 0, is less than 2. No, whoops. Less than x is less than 0. 0 is less than x is less than 2, and greater than 2. And then as for testing, x minus 2 squared, x plus 4, and x to the 3. So any number less, okay, so first of all of these are positive. anything less than 4, that's going to result in a negative because it won't add up. And then any negative number to the power of 3 is negative. That goes for this as well. And then both of these are positive because any positive number to the power of 3 is positive as well. If it's between -4 and 0, it won't be enough to make this negative, so this will be positive. And then, of course, both of these will be positive because they're greater than 2. So, negative negative makes a positive. This is positive, positive, and a negative, negative. These are all positive. So, what we end up with is positive, negative, positive, positive. The reason that this is like this is because the 2, as we'll see later, actually has a multiplicity of 3. It's a critical point, but it's not going to be a minimum or a maximum. Whereas 0 is just an asymptote. So the only actual point here is going to be -4. So it'll be a local maximum there. So x equals -4. If we plug this back into our original equation, x minus 2 to the 3 over x squared. If we plug this in, this becomes -6 to the 3, and just a moment, this is 16, $216 over 16, but it'll be negative there. And then when we actually calculate that, that's going to be -13.5. Just double check that here. Yeah, -13.5 is our y value. So we'll have a maximum at -4, -13.5. Then let's just write down our increase and decrease here. I'm just going to use text here just because it'll be a little easier. Maybe I'll bold it. Whoops. This will be increasing at negative infinity to -4 u 0 comma 2. Actually, because this isn't an asymptote, it's not going to skip over 2, and it's just going to go straight to infinity, or positive infinity. So yeah, it's just going to keep increasing. Well, because it flattens out there. No, I suppose because it flattens out, it's not increasing at that specific point. So it would be u comma 2 to positive infinity. Because at the point of 2, the slope is completely horizontal. It's not increasing or anything. As for decreasing, at -4 to 0. Oops. -4, 0. Perfect. And then as for concavity, I'll also have the second derivative on a document in the description of this video. So f double prime x equals x minus 2 24 over.
You got it. Zip on pants.
Go. I'm sorry, I'm recording something. I'm doing a
Okay, I'm leaving
video. Oh, thank you. Looks delicious. My mom brought me a blueberry cupcake.
Here's 2.
Oh, I don't know if I'm gonna eat 2.
You have to eat 2. Just eat both of them. Just do it.
I'll try. Alright, anyways. I guess we have blueberry cupcakes to share. Alright. X to the 4. So this is the second derivative. The 24 is kind of irrelevant, but 0 equals x minus 2, 2 equals x. That's one of our values there. And then x to the 4, this is our asymptote again. 0 equals x will be right there as well. Number line, one at 0 and one at 2. Here we'll see that the concavity will change between the two here, showing how it will level out there and then go up. So the concavity will be down and this will be up, which is how it should turn out. Less than 0. 0 is less than x is less than 2, and greater than 2. X minus 2 and x to the 4, f of x. These will be positive. Anything less than 0 is going to be a negative here. Still less than 2 is still going to be negative. So it'll be negative, negative. And then bigger than 2 will make this positive, and this will be positive here. So that means that in terms of concavity, we will be, oh man, I just put my hand in the cupcake. My fingers are covered in frosting. 1 second. Yikes. Okay. Anyways. Gotta be careful there. Alright. It's gonna be, I need to move these cupcakes. These cupcakes need to go away. Alright. Concave down at negative infinity 0, concave, hold on, because 0 is the asymptote there, it'll also be 0 to 2, then concave up at 2 to positive infinity. Which we can see here. Decreasing. So, yeah, it'll be, concave down, concave up. And then our point of inflection, there obviously isn't one at 0, because that's our asymptote. But for 2, x equals 2, well, we actually already calculated this, because this was our x-intercept. So, POI at 2, 0. And those are all of our numbers. So we have gone through intercepts, symmetry, asymptotes. Oh, I forgot the slant asymptote. If we look right here, x minus 2 to the 3 over x squared. This is 1 degree higher than the one below it, which means that we have a slant asymptote. The expanded form here is going to be x to the 3 minus 6x squared plus 12x minus 8 over x squared. Now, in order to find the slant asymptote, we are going to have to do a little bit of division here, long division. Now, actually, it is important to note here that we have some invisible numbers. Hold on. X squared plus 0x plus 0. Now, as for this equation here, in order to make x squared equal x to the 3, we need to multiply by x. This multiplied by this, x to the 3, we'll get rid of it. And these will just be 0x squared plus 0x. So this will stay as negative 6x. These will cancel out. Squared plus 12x. Bring this down, minus 8. We can still fit this into here. We just need to multiply by negative 6 here. Negative 6x squared over 0x plus 0. Whoops, that's not a 0. 0. Ooh, that was weird. So these will cancel out. We will get 12x minus 8. So that means that our final answer here is f of x equals x minus 6 plus 12x minus 8 over x squared. Which means that if we take this out here, y equals x minus 6. This is our not a horizontal asymptote, but our slant or oblique asymptote. Equals x minus 6. Now, we finally have all the info we need. We have gone through intercept, symmetry, asymptotes, slant asymptotes, increase, decrease, max or mins, concavity, and then points of inflection. So I have actually already graphed this here. I just want to pull up the layers here. Where is it? No. No. Whoops. I realize that I'm sharing this screen, so I'm going to have to... Okay. So these are our graphs here. So this first one here, this is our so we got a slant here, slant asymptote at y equals x to the 6. I should probably also just clarify it that there is another slant asymptote at x equals 0 here. Just right there. Or, yeah, x equals 0. So we can see here, before -4, it is increasing, and then after -4, it is decreasing, and then at after 0, it is increasing again, and then it increases again after it levels out at 2 there. We can see here that the concavity in here is just pointing down here, and up here, which follows what we've got here with concave down, here, and up there. Infinity to 4, 0 to 2. Yeah, looks good. And now I have also graphed here the first and second derivatives. We can see that where the first derivative intersects with the graph at -2 here, or sorry, +2 here, matches up with our critical values. So at 2 and -4, we have a critical value, so we have a maximum, and then we also have this critical point that has a multiplicity of 3. And then on the second derivative graph, we can see that it only intersects at 2, 0, which happens to be our point of inflection as well. So that is the curve, first derivative, and second derivative. All points of interest. We only have 2 points of interest because The x-intercept is also a critical value and is also the point of inflection. So I think that's everything. Yeah. Give me 100%, pretty please. I'd appreciate it. Thank you.